This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're in Unit 9, talking about Section 9.4. In this video, we're going to specifically talk about unit vectors and how to find them. So let's go ahead and skip down to the section over here where we talk about unit vectors. So be careful that you don't confuse this with standard unit vectors. Okay, so different than standard unit vectors. Okay, we talked about those before. That's I is a unit vector that goes in the x direction, and j is a unit vector that goes in the y direction, and we can represent vectors using those two standard unit vectors. Now the only thing they have in common is that they both have a magnitude of 1. So when we talk about just a unit vector, again, it's a vector with a magnitude equal to 1. Let's highlight that here, to 1. Okay, and the way we calculate it is we take the vector and we divide it by its magnitude. And this will give us new components. You might think of them as coordinates for the vector. So let's take a look at an example. We want to find a unit direction, a unit vector in the direction of v. So let's take a look at our graph here, and we'll get some more explanation as we go. So I've got 7, negative 3, 1, 2, 3, 4, 5, 6, 7, negative 3. So here's my vector. The idea of a unit vector is I want to find a vector that goes in the same direction as this one, so down and to the right, but only has a magnitude of 1. Because the magnitude of this vector is definitely not 1. We could find the magnitude of v. So let's do that. The magnitude of v, that's just the square root of the sum of the square of the components. So square root of 7 squared plus negative 3 squared. So that's the square root of 49 plus 9, which is the square root of 58. So now that we know that this has a magnitude of 58, I can find my unit vector. A lot of times we'll use the variable u for unit vector. That's our vector divided by the magnitude of v. Okay, and this vector, just highlight this to emphasize, this vector was 7, negative 3. So then this is going to be 7, negative 3, and we found that the magnitude was square root of 58. So we'll divide that by the square root of 58. And what this statement here is telling us to do is take each of the components and divide it by the magnitude. So I'll take my x component and divide it by square root of 58. And I'll take my y component and divide it by the square root of 58. Alright, and then since we have radicals in the denominator, we'll want to rationalize those. If you have questions about how to rationalize, make sure you check in with me when you see me. So we'll multiply this by square root of 58 over square root of 58. So we'll get 7 square root of 58 over 58. And we'll do the same with the y component, so we'll get negative 3 root 58 over 58. And here we have another vector. So this is a vector. This is a 1 unit length vector in the same direction as 7, -3. Alright, so if I was to draw this in here, its coordinates are 7 root 58 over 58 and -3 root 58 over 58. So it's going to fit in somewhere in here. Okay, this has a magnitude of square root of 58, which is between 7 and 8. So, you know, this unit vector is going to be between a 7th and an 8th the length, so somewhere in here. So this little vector here, this is the unit vector. Okay, notice it goes in the same direction, but it's only 1 unit long. If we were to measure it, it would be exactly 1 unit. Alright, so that's it for unit vectors. Why don't you move on to the next video. Again, if you had any questions, make sure you ask me the next time you see me in class, and we'll see you next time.